The main goal of the eye is to make sure that light is able to pass from whatever you're staring at through your eye and then focus on the back of it, which we call the retina. So your eyes are able to focus or change their focus based off of a couple different things. So you have like muscles that help change the shape of your lens. You have your pupil, which can open and close to let in light. So if you're at all familiar with how cameras work, our eye is pretty much the same idea. So like the same idea between like how much light you let in. So your ISO, like if I don't know if I have any like people that are really into cameras, but you have ISO, how much light your camera lets in, and then you have your focal length, which is like what's your focus. But our eyes work kind of the same way. So these are the main points. We're going to go through them in order, and along the way we'll talk about some interesting parts. All right, so let's talk about the cornea. So cornea is the first thing that light passes through. It's clear and it helps protect your eye. So if you ever get a scratch on your eye, this is what's like that protective outer layer that prevents damage, because your eyeballs are pretty sensitive, right? They're squishy, they can be damaged very easily. So this prevents, and if you think about your glasses too, right? You want to make sure that you don't have any scratches on your glasses. You don't want to make sure you don't have these scratches on your eye. One interesting part about corneas, so when you have a transplant, one of the big problems with getting an organ transplant is it's really hard to find a donor. You can't just give anybody your organ. So we talked about this a little bit before, but if you're trying to get, say, an organ donation, what's one thing that they want to make sure like is the same between you and the person that you're getting the organ from? So say like I was going to donate my kidney. Yeah. So Gabby, you got it. Blood type, right? Yes. You got it. You're absolutely right. Blood type is one of the big thing. Cornea doesn't matter. Your cornea is this outer layer that kind of doesn't receive any blood vessels. It gets its nourishment and other stuff from the surrounding tissues that kind of move out. But the interesting part with this is it doesn't matter what your blood type is. You can literally give the cornea of one person to another person without any chance of rejection. So this is where it's kind of the weird thing where you can have this transplanted without any worries. And that's our cornea. So that's kind of the outer layer. You can see it peel off. I was going to show you guys cornea transplant surgeries, but I don't know about you. I'm kind of squeamish when it comes to needles and scalpels poking the eyeball. But well, yeah, we'll put a poll up and see if that's something you guys want to take a look at. Or I'll put those resources up in case you want to be brave and check them out on your own. All right, the next one. I love this GIF, and there's a couple cool ones. Next one's our pupil. So our pupil is the black opening that lets in light. So you can have your pupils change. So if you say you go into a movie theater, yeah, God, it's been forever since we're in a movie theater, but say you're coming out of a movie theater on a summer day, right? As soon as you walk outside, how would your eyes change? So if you're going from a dark movie theater to like a bright outside, so you go through one of those exits because you don't want to go through the lobby, right? Some of those you can just go straight out the back, right? How would your eyes change if you go from a dark movie theater to like a bright sunny day? Think about the difference between what your eyes have to do in a dark theater versus outside, right? So our goal is to make sure that we get enough light in our eye. So if it's dark, you want your eyes open all the way to get in all of that light. That's how I would say that people get smaller. Yeah, you're absolutely right. So it's going to get smaller because we're used, after time, like our pupils start to open up. We adjust to the darkness. I think it said it's like half an hour for eyes, half an hour to an hour for eyes to fully adjust. So we have what we call constriction. They get smaller with time. So what we're going to look at for this video here is, can the pupil disappear? Can the eye, can your eye close all the way down? No, your pupils can get really small, but it can't close up all the way. I don't think. That's a really good question. I gotta look that up. Let me just double check that. It's kind of like a shutter that opens and closes, but I don't know if it can close all the way. It can get really tiny, but I don't know if it can close all the way. That's a good question. I'll take a look when we're looking at the next section. All right. So for here, we're going to look at, this is a reflex that you can test to see if there's like neurological damage. So a lot of times with reflexes, this is something they may check to see if sometimes drugs and other things affect like reflexes in your body. One of the if you've ever seen something where it shows someone doing a sobriety test where they say follow my finger, right? What they're looking for is your eyes start to jerk. You don't have smooth eye movements. And that's why, like, when the cops are saying follow my finger and they're testing you to see if you're sober or not, when you're intoxicated, your eyes start to jitter. Like, it's not smooth when it gets to the ends. And I'll put something up to show that. We'll take a look at that tomorrow too. I'll add that. But for this, I want to show kind of how the pupil works with this.
Hey everyone, it's Sarah.
Oh, I thought I moved it. Okay. We're not going to watch the whole thing. Sorry. I just want to take a look at the last part. So this is a nurse that is giving a eye exam. So we'll take a look and see kind of how to check the pupil reflexes. And this is cool. Like there's so many nursing videos, which is awesome. I love it. All right, so we'll go ahead and take a look at this.
And we are going to be looking for a direct response, which means whenever we shine light into the eye, we're shining light, we're looking at the pupil to see if it constricts. And we're also going to look for consensual response. It's when we shine light into this eye and we're seeing if this pupil constricts simultaneously with this eye.
So let me just pause that really quick. This is what the cool part is. If you shine a light in one eye, there's a consensual response, meaning that the other eye does the same action. So even though your right eye is getting the extra light, your left eye should constrict too. And this is kind of what they're testing for.
Then we're going to look at accommodation response whenever the patient fixates themselves on an object far away and we see how well their pupils respond whenever the objects move closer to them. So let's get started. The very first thing we want to do is we want to look at the eyes and we want to look at the pupils and see how round they are, make sure they're equal in the size of them. And on your pen light, you have little sizes. And usually normal sizes of pupils are 3 to 5 millimeters, and our patient here, size of his pupil is about a 5. And whenever you're checking for direct and consensual response, you want to dim the lights like this. And what you want to do is you begin by shining the light in one eye, and you're looking at the response of the pupil. And as you can tell, his pupil dilates very nicely and briskly. That's the direct response. Now we're going to look in this opposite eye whenever I shine light into this eye and see how this pupil responds. So let's do that. His pupil responds just like the direct response. It constricts and it dilates back normally, and you want to shine it in both eyes, just back and forth. You can also do what's called the swinging test with this, and what you do is you swing the light in between the two eyes every 2 to 3 seconds like this. And you're just watching for pupil.
So you guys kind of get the idea behind this, that we can kind of see these reflexes. This is something that they test, right? I like the explanation. It's kind of hard to see the other eye. You can't see that consensual response, that when one eye constricts, the other one does too. But this is something that they test to see if there's damage with an eye. So say someone has vision problems, they may check to see, are both eyes working correctly? So this can be used to help diagnose maybe some diseases, some neurological problems. We'll take a look at the different nerves that are coming from our eyes to our brain. There's actually quite a few. So if this wasn't working for you guys, you can go back at some point and check it out. So what we'll do is we'll take a minute or so and have you fill in your response here, and then we'll keep going for our lecture today. So we got a chance to look at the pupil.
Hey, everyone.
Going down our path, right, we have our cornea, we have our pupil. Oh, it should be, oops, sorry, it should be P-U-P. Our pupil, our lens, our cornea, moving down. So we're at the pupil. We have the lens, the retina, and the optic nerve left. So let me go. I don't know. There you go. All right. So our lens. Its job. It's this clear. So again, it's clear because light has to pass through a curved structure. Along with the cornea, the lens helps us focus light on the back of the eye. So in order for us to see something clearly, we need to change light so it hits in the same place, the back of your eye. So we have to kind of bend the light rays. This idea of bending light rays is not that foreign, because if you look in a mirror, you can see like the stuff bounce and come back. Another way that we can see light bend is if you look at like rainbows. Rainbows are light that bends off water droplets. You get a glass of water, you put a pencil in it, you can see that it looks like it's kind of cut in half. That's light bending as well. So not to get too far into it, all we really need to know is that your lens changes shape based off of what you're looking. So lens must bend light from nearby objects more than it bends far away objects. So one way to think about this, right, is if you're looking at something far away, all that light is a lot closer together because it takes up less space. So you're not getting information from all around you. So if you're looking at something close, you're getting more light from all around your vision. If it's really far away, it's just like kind of a narrow stream. So you can think if it's far away, you're kind of getting these long parallel beams. If it's close away, you're getting light at all these different angles. So what you guys need to know is that your lens is flat for far objects, and it becomes more round and more squished when you're looking at near objects. All of this happens without you thinking about it. It's all just instinctual. So your eyes change focus. The lens changes shape. So if you're looking at like something in front of you and then you look something far away and you just kind of switch, you're literally squishing, changing the shape of your lens in order to see. So this kind of shows the same idea. The way that these get the lens to change, like anything in our body, how do we get motion to happen? We use muscles. So in your eyeballs, you actually have muscles which help change the shape of your lens. If you need glasses and you have like a hard time seeing, one of the problems is you might have like eye strain where your eyes kind of start to hurt after a while, especially if you're reading something. You can imagine it this way, right? If your muscles are always having to contract to squeeze that lens, if you're reading something all the time, you get eye strain where the muscles in your eyes actually start to get tired and start to not work as well. So it's kind of like if you imagine where you squint, right? Like if you're like trying to read something, you squint, you're changing the way that light comes into your eyes. So that's what we need to do for the lens, right? Far objects, we have a flat lens, muscles relax. Near objects, muscles contract, and you get a more round lens. So the idea is if you had something where you don't have the muscle responding, like you don't change the shape, you're not getting light to hit the right spot. Another way to think of it is like a projector, right? If you're projecting an image onto a screen, you have to change the focus, because if you get the screen too close, it gets blurry. If it gets too far, it gets blurry. It has to be the right distance. Your eyeball can't change shape, right? Your eyeball doesn't get longer or shorter. So we change the focus on the eyeball this way. All right, so next up, this is going to be our important part, is the retina. So your retina, and all these bold vocab terms you're going to see a little bit later for the review questions. Lens focuses light on the retina, which covers the back inside of their eye. So we're looking at this layer right here. So this is our retina layer here. Don't yell at me.
Hey everyone. Hey everyone.
Stop. Sorry. Gosh, that's so annoying. All right. So this is what our retina looks like. So that's that layer here. We have cones and rods. Rods are literally that. They just look like rods. Cones are look like cones. These are what's responsible for us actually seeing. When light hits these receptors, they send a signal to our brain. It's not that different from like what we think of like solar panels, right? Solar panels, light hits a solar panel and it's converted into electricity. In our eyes, we have these cells which collect light, and they change it not to electricity, but to a signal that our brain takes in. So your brain has a couple things. You have cones and rods. Your rods let you see in low level in the dark. You have a lot more rods than you have cones. The cones, there's three colors. There's red, there's blue, and there's green. And these help us see different colors. So like, and you can see this with like pixels and like, we kind of understand color a lot more from technology, but red, blue, and green, every image or every color, it can be made up of some combination of red, blue, and green. So why can't we see so well in the dark? That's a good question. So the problem with it is we have a lot of rods to help us pick up on low light, but our eyeballs don't, there's not enough light around us to send the signals. So we have more rods to help us, but we still don't have the best night vision. One thing that you may see is if you ever look at a cat or animal eyes, if you shine a light in an animal's eyes, they glow at night, right? So say like you're driving down the road, you can see like eyeballs glowing on the side of the road. Animals can see better at night because they have kind of this reflective layer. It's called the tapetum lucidum. It's this reflective layer that helps increase the amount of light they get in their eye at night. So for us, even though and that's a good question, even though we have more rods, we need more rods to pick up those signals because they're a lot weaker. But no, that's a good question. We'll take a look at that tomorrow too with why animals can see a little bit better at the dark. Okay, so the last part that we have here is our optic nerve. I like this because it kind of shows what's going on. The lens focuses light here. So if we look what's going on, light's going to enter. So say we're looking straight on, light's going to enter, go straight and hit the back of our eye here. And it's going to be picked up by the retina. So this layer of like film. All these signals are going to be sent down to this like nerve that goes to your brain. So we have a bundle of neurons that goes straight to your brain. And these chemical changes start impulses that travel to our brain through what we call our optic nerve. So the optic nerve is the wire that connects your eyes to your brain. But one of the interesting parts is This area where it connects, you can't sense light there. So your eyeballs have a blind spot where your optic nerve connects, and we can actually see that. And that's kind of what we're going to be doing for our next activity. So this is kind of like our little lab that you can do at home right now. So we're going to have you guys find your blind spot. And again, our blind spot is this where your eyeball connects to the rest of your body. There are no receptors here that pick up light. All right. So if we look at what the blind spot is, if you imagine where the nerve connects, if you draw a line going straight out your eyeball from there, this is where your blind spot is. So if your center of vision, so if you put a finger to the center of your eye, if you move it a little bit out towards the sides of your body, towards your hands, laterally, right? Remember our terms, laterally off to the sides. You actually have your blind spot. Problem is, your eyeballs are really good at processing information and putting together a signal. You know how I can tell you, and you could agree with me on this, right? Your brain is really good at filling in images and getting rid of extra information. So you're staring at the screen. Do you guys see your nose? Well, now you might, because I said it, right? But our nose is in front of our eyes the whole time and we don't see it. If you wear glasses, right, you don't notice the frames around it unless you start thinking about it, and then that's all you can see. So I'm sorry if you wear glasses and have a nose, because that's all that's all you're staring at right now, right? But our brain does a really good job of getting rid of extra information and filtering out stuff and focusing only on what we're looking at. So we have a blind spot in our eye, but we don't see it because imagine like you have a picture, right? And everything, or like you have a circle and you don't know what is in that circle, but everything around it is a certain color. Your brain just kind of says, okay, I know what everything around it is. I'm going to say that what's missing should be the same. So you can kind of your brain fills in the blanks. But there is a spot where you cannot see something, and we're going to test that right now. So if you guys go to this link here, testing your blind spot, there's a few different ways you can do this. So this is something that's kind of fun to play around with. So if you read through this, we're going to need a piece of paper for this. So if you get a piece of paper, like just a standard piece of paper is 5.5 by 11. So if you just take a regular piece of paper and fold it, so actually here, you just take a regular piece of paper and fold it. Or fold it top to bottom. The distance from the top, half that distance right here, is going to be your area. So they want you to draw a plus sign on one side and a circle on the other. And that's going to be roughly about 6 inches. So that's kind of the setup for this. It says about 6 to 8 inches. So I want you guys to read through this and see if you can find your blind spot. You should be able to see that once you move it close, you should be able to see at a certain point, you see the plus sign disappear. So we'll take a few minutes, see if you guys can find your blind spot.